All right, welcome back, everybody. Here, what we're going to do today is I'm going to do a quick video to recap what you learned yesterday, and then we are going to come back in a little bit and do another video on the new stuff for today. And the recap, what we're going to do is we're going to talk about what polar is, and we're going to talk about the difference between a rectangular form of a point and a polar form of a point. Okay. Now, a rectangular form of a point is what you've done your entire lives. The point XY. Polar form is this new guy where what we talk about is R and theta. Now, what's the difference? Back in the day, you had an x-axis and a y-axis. All right. Here's your x-axis. Here's your y-axis. And for any random point, let's say the point was the point 4, 2. All right, for any random point, you went right 4, you went up 2. That was rectangular. Now, what polar says is there's a pole here in the middle, call that the pole, and we measure the directed distance from the pole, we're going to call it the radius, and the directed angle that this guy turns right in here, we'll call that theta. Well, you might have remembered, we dropped this down and way in the past. This is 4, this is 2. All right. I don't even need 4 and 2 anymore. Let's just call this x, let's just call this y, such that we know x squared plus y squared equals r squared, or the tangent of theta is equal to y over x. And we learned, hey, look, the cosine of theta is x over r, so x is r cosine theta, and the sine of theta is y over r, so y is r sine theta. These 4 equations here are very important in the concept of polars. Can't lose those. Those are how we convert equations, is how we convert points. That's how everything works. So let's start with this first point, the point -3, 3. Now, if I overlaid, this is not how it's going to look all the time, but the first time I like to do this, I like to put on top of the polar axis or the polar graph an x-axis and a y-axis. The x-axis is actually, the positive x-axis is called the polar axis, not to be confused with what I said. Now, so here, the point -3, 3 actually went left 1, 2, 3, went up 1, 2, 3, and it's probably going to land right about there. Okay, that's the point A. Now, for point A, it has a directed distance it is from the pole. As you can see, it's 1, 2, 3, a little bit more than 4 units away from the pole. And it has a directed angle from the positive x-axis. Now, if you look at this directed angle from the positive x-axis, it's about halfway between the positive y and negative x-axis. So we can figure out what that angle is in there. Well, how do we do this? This is x and this is y. So we said that x squared plus y squared equals r squared. So r squared is 18. R is the square root of 18 units away. Technically, it's plus or minus, and we will cover that in a little bit. Now, where do we go with that? R is equal to root 18. We're going to simplify that. That's just 3 root 2. You had an a root 2 is what you might have remembered. Now, the tangent of theta for theta is y over x. 3 over -3 is -1. Now, when I do inverse tangent, I always make it the absolute value. Y, theta is the inverse tangent of 1. The reason I do that is I find this reference angle in here. That reference angle is 45 degrees. So the angle that this guy rotated is 180 minus 45 degrees, or 135 degrees. So point A is 3 root 2 units away from the pole at a directed angle of 135 degrees. Now, it's easier for me and many of you to write that as 3 pi over 4. That's probably the most recognizable one we'll use in terms of radians. Now, when I came out here, do this pretty quickly. 0, -2 is here. Doesn't take a genius to see. All right, well, that's 2 units away at an angle of 3 pi over 2. So I could actually say x squared plus y squared equals r squared if I had to. It's equal 2 units away, and the tangent of theta is -2 over 0. Now, we learned that tangent is undefined at pi over 2 or 3 pi over 2 or lots of places after that, correct? Well, you look here, this is the point 2, 3 pi over 2. Now, you also learned was there's other ways to write that. You could have written this as the point -2 pi over 2. Remember me saying that actually r here is plus or minus 2. If I went in the direction of pi over 2, but I went backwards 2 units, I'd be here at point B. I could have done the same thing with others, and we'll talk about that on the next page. Now, on the next page, we're going to convert the point from polar to rectangular. So we're going to start with polar, and we're going to go to rectangular. So this is r and theta. So what do we got? Well, x is r cosine theta, and y is r sine theta. So let's just start real quick. The point -4 pi, the direction of pi would take me here. We're going to go backwards 4, 1, 2, 3, 4. This is actually point A. So x is -4 times the cosine of pi. Y is -4 times the sine of pi. Now, remember, cosine of pi is -1. And the sine of pi is 0. So this actually is the same as the point 4, 0, where it went right 4 and up or down 0. Now, what's interesting is this is in rectangular form. But it's also the same in polar form. Why? If I didn't rotate anything and I went +4 units away, I'd land here. Now, there's no way of knowing which form you're in unless it tells you. Okay. Now, point B, 5 pi over 6. Well, where's pi over 6? Well, that's right here. 1, 2, 3, 4, 5. That's right there. And if you think about it, point B is 1, 2, 3, 4, a little bit more than 4 units away. 1, 2, 3, somewhere between 2 and 3 units in the y direction. So x is 5 times the cosine of pi over 6, which is 5 times √3 over 2. So x is 5 √3 over 2 units to the right. And y is 5 sine of pi over 6, which is 5 times a half. Y is 5/2. So that point is the same as that one. Now, my y value is easy to see, 2.5. Great. My x value, 5 √3 divided by 2 gets me 4.3 units away. 1, 2, 3, 4.3 units away. There you go. Now, to continue, this talks about identifying all the coordinates. Now, if this is pi over 6, here is pi over 12. A lot of times we like to use pi over 12 because 1 pi over 12, 2 pi over 12 is pi over 6, 3 pi over 12 is pi over 4. And if I use pi over 12, I'll get my 30s, 60s, and 45s. Now, 3 pi over 12 is the point 1, 2, 3 right here. Now, if you think about what that means, the directed angle is pi over 12 units from the positive x-axis, and it goes 3 units away from the pole. Now, another way I can name that point is I could take this and I could go around the full circle one more time. So if I wrapped around pi over 12 plus 2 pi, I would land there. So another way I could write this point is 3 and whatever pi over 12 plus 2 pi is. Well, we know that to be 25 pi over 12, correct? One way I could do it is also go backwards. What if I went backwards and I got, ooh, what would that be? 23 pi over 12 negative? So I could have done pi over 12 minus 2 pi. Well, what if I did more than 2 pi? What if I did 4 pi or 6 pi or 8 pi and all that fun stuff? So point P could actually also be written as the 0.3 pi over 12 plus 2k pi, where k is an integer. That should look very familiar to you. Now, there's another way to do this, though. Because we said before is I could actually point in this direction, but go backwards 3. So I could have said, all right, well, point P was negative 3. And how do I get from pi over 12 to here? Well, this is pi. This angle in here is pi 12. So this is actually 13 pi over 12. So if I went in the direction of 13 pi over 12, but went backwards 3, I'd be at the same place. So what did I do? I took this and I added pi. Well, again, if I was at 13 pi over 12, or plus 2 pi, or plus 2 pi, or plus 2 pi, so this point could also be the point negative 3, and 13 pi over 12 plus 2k pi, where k is also an integer. Now, it's a lot easier to sit here and say, all right, what did I do? How did I figure that out? It's an odd number of rotations. There are other ways to write this, but this is the simplest way. Okay. You can do it one more time. One more time, we're going to do this. We're going to do it with degrees, because some people, degrees is a lot easier to recognize. So it's going to start with 5 and 70 degrees. Well, now 70 degrees, this is 30, this is 60, it's somewhere about here. And 5 units away is 1, 2, 3, 4, 5. Here's point P. So another way to write point P is to go another 360, and another 360, and another 360. So I could write this as 5 and 70 degrees plus 360 degrees times k. Again, where k is an integer. Okay. Now, I could have also gone backwards. If I follow that 70 degrees this way, through the pole, I want to know what this angle is to rotate all the way to here. Well, this is 180 degrees, and this in here is my reference of 70 degrees. 180 plus 70, 250, right? 20 degrees, 20 degrees, you get the same idea. So I could have a negative 5 and be a rotation of 250 degrees, and I'll be in the same place. Why? Because if I rotated 250 but went backwards 5, 1, 2, 3, 4, 5, there I am. Well, it's the same idea. Every time I land on that 250 degrees, I will have the exact same point. And that is the video that will hopefully review what we did yesterday. I'm going to come back in a minute. Have a good day.